So welcome to clip number 8 of my making of the John Smith Busker organ. The last clip I made, I just completed a small table so that I could sand evenly the upper lips of my pipes to give them an even chamfer, and my early attempt had not been very successful, and what had happened is that in making a little chamfer on the lips of the flutes, the chamfer on each lip had been uneven. Each chamfer was at a different angle which reflect the light differently, and it made the instrument a facade look scruffy, and so I decided to chamfer lips tidily. So they're now all done, and here you can see 17 of the 20 pipes, the 3 big bass pipes I have had set aside here. Those are the 3 big bass pipes, so this gives me the whole set of pipes, and not only are my pipes are completed with the upper lips chamfered, as you can see, but the pipes have been drilled at the back with holes and voiced, and I'm relatively satisfied with the sound. This pipe is the larger of the front pipes. It's an E pipe, again prepared with its hole, and as these are closed pipes, if I close the end and blow in the hole, you can hear the sound of the flute. That's the lowest of the facade pipes. This little D pipe, very small as you can see, is the highest of the facade pipes, and it too has been voiced, so it sounds like this. So I may, in fiddling with the pipes and making their stoppers, be able to improve the sound. We will see. But that really, for the moment, is the pipes. And now I move on to the bellows and a little bit of bellows theory. And so now I'm moving on to the bellows of the instrument. The bellows, an exceptionally important part of the busker. They need to supply an adequate quantity of air to the 20 pipes in a regular manner, and at first, in looking at the John Smith plans, the bellows looked like one of the most complicated parts of the instrument, but in fact, if you follow the plans and simply go about cutting out the pieces for the bellows as they're drawn by John Smith in the plans, it then becomes relatively self-evident as to how the various pieces fit together. And also, of course, he sends with the plans a DVD that actually shows you John assembling the bellows. But I think the most important thing is to understand what they're doing, and when you understand what they're doing, the assembly of them becomes relatively simple. And so this is half one of the pairs of pumps that will send air into the reservoir at the back, not yet out of its clamps and drying, is the other half. And in fact, this is the bottom, the inside part of the top part, and this is the top, the outside part of the bottom part of the bellows. You have the same pieces here in that direction. This will be the bottom, and this will be the top, the 2 parts of the pump that will sit together, and this part, this edge and this edge, will be hinged together so that they can open and close like this. The top board will be fixed, and the bottom half is actually moved by the treadle action of the hand crank, and of course the envelope of leather around the edge is what captures the air and sends it into the reservoir box that will sit on the top. The air will enter by holes drilled in the base. A valve inside will stop the air escaping from the base and send it through holes in the top that send it to the reservoir. And it will also be important in the reservoir box on the top to have an escape valve, because if I keep pumping but no air is needed by the pipes, the bellows would eventually explode. And so I have 2 pairs of pumps, holes to make, valves to put in place, and the reservoir box to make as well. And I've been hanging around, but I have been trying to make these parts of the instrument as tidily and nicely as I can, drilling them and cutting them, and just paying attention to the corners and the cutouts, and I often work in a rather sloppy fashion, but I promised myself at the beginning of this project that I would take my time and be patient and work as nice as I could, and I'm trying to work in that tradition that's often said about the medieval builders, that paid as much attention to detail of the invisible parts of their structure or what they were making as they did to the parts that were visible, because in the eyes of the medieval builder, everything they made could apparently be seen by their god, and so they paid attention to everything. So these bellows will be hidden away inside the instrument and in fact covered with leather, but by the time I've finished them, varnished them and sanded them, I hope they'll look tidy and smart, and of course work efficiently as well. And so in my next little clip, you should see the bellows, the reservoir box with its safety valve, and of course the hole dressed in leather. Thanks for watching. So just a little bit of theory before I get back to working on my bellows. As I build this John Smith Busker organ, I'm trying to learn something about the functioning of a mechanical instrument, and I've understood now that the particularity of the John Smith Busker is that a paper roll with holes in it passes through a pressurized air box, and when there's a hole in the paper roll, air from the pressurized box goes through a tube into the flute, whereas larger mechanical organs, French ones in particular, and I think probably fairground organs, use a system of valves. And I've made a valve here just to learn the process myself, a membrane valve it's called here, and it works quite differently, because here there's a constant supply of air that goes towards the pipe, but that constant supply is closed off by the valve, and the valve is operated by a little tube, and when the tube is opened, the valve opens and air goes to make the flute a sound. And of course what opens and closes this tube here is the paper roll, so no need for a pressurized box. And the valve is relatively simple. This is a large and coarse version of an apparatus that can be much finer. The top part of the valve consists of an oval chamber, one hole from the top of the chamber to the exterior, otherwise the rest of the chamber is closed. The bottom part of the valve consists of a hole that runs vertically through the block. I've stuck some plastic piping in there to give an air arrival. The second hole runs halfway through the block, and in this case turns at a right angle so that it can go off to the flute. And then the last part of the valve is a membrane. This piece of rubber, but generally you would use a fine leather membrane, the whole of which goes over the center of the hole of the air arrival, and then the chamber would sit on top. And what happens with this is that if I close the top valve, so paper running over with no hole in it, air constantly comes through the arrival, goes through the membrane into the upper chamber, where pressure will build up. Because pressure is building up in that upper chamber, it will press down on the exit part, blocking the air access to the flute. But if I have that valve sealed and I open the top, because paper's passed by, there's been a hole, then what happens is that there'll be a leak. Air will come to the membrane, a certain amount of air will leak out through this hole, and that will relax and reduce the pressure in the chamber at top, enabling the valve membrane to extend and the air to pass beneath the membrane into this hole, down, out, and to aliment the flute. So in a large fairground organ or system, this a valve controls air being sent to the flute, whereas on our John Smith Busker, the air produced by the bellows that I'm building will send air to a pressurized box or container, from which it will go then direct to the flutes in the instrument. And there it is, working. The valve and its membrane.